Okay, so welcome back to Ionic Bonding Tutorial B. So we're talking again how ionic bonding works, and we're going to give some more examples of it. We used sodium chloride before. Now we're going to step it up a little bit and make it a little bit more challenging. So here you see I've got my compound calcium chloride. So I've got my calcium and I've got my chlorine joining together, metal with non-metal, to form an ionic compound. So remember what we need to do. We need to draw out the outer electrons for each of these atoms. So let's find calcium. Now calcium is in group 2. So you should now realise and remember group number tells us the number of outside electrons. So calcium will have 2 outside electrons. Chlorine is in group 7. So that will have 7 outside electrons. So draw my chlorine and pair them up so it's easy to see them. 2, 4, 5, 6, 7. Okay. Now, if you remember, calcium, the metal, will want to lose its electrons to gain a full inner shell. There is an inner shell here that's full, 8 electrons. And chlorine needs to gain 1 electron, as you can see, to get a full shell. Everything wants to be like group 0, group 8, full shell stability. So let's see that in action. So calcium gives up its electron to chlorine. This therefore makes the chlorine very happy, because now the chlorine has got 1, 2, 3, 4, 5, 6, 7, 8. And remember, before chlorine had no charge as an atom, protons, electrons are the same number. Now we've got a slight imbalance because we have more electrons coming in, 1 more electron negatively charged, so that becomes -1. So now chlorine atom has become the chloride ion, i.e. Cl-. Let's go back and look at calcium. Calcium is still not very happy because it still wants to lose that 1 electron. Now what are we going to do? Chlorine is full. We can't do anything more with that chlorine, but we have a little trick up our sleeves. We're allowed to use another chlorine to get rid, so to help the calcium get rid of that last electron. Okay, so as you see, chlorine has 7 outside electrons. If this calcium was to give it electron up, it will happily become the extra electron, 1, 2, 3, 4, 5, 6, 7, 8. So it's now happy. The chlorine becomes a chloride ion. It's got that extra electron, minus charged, -1 electron. Now let's go look back at the calcium. Now the calcium has lost its 2 outside electrons. It's become much happier because it's got now a fuller inner shell. So how do we tell everybody it's lost its 2 electrons? Well, electrons were negatively charged. It's lost 2 of those negatively charged particles. It becomes 2 plus or +2. So fantastic. Calcium's happy, chlorine's happy. We can also now write the formula for calcium chloride, because we have 1 calcium. Just put Ca. The metal always comes first in formula writing for ionic compounds. Let's go and look at the chlorine now. Cl. I have 2 of them, 1, 2. So this is when I use my little subscript number 2 here to tell me I've got calcium chloride, CaCl2. 1 calcium, and if we don't show a little number there, that means it's 1, and 2 chlorines tells me it's Cl2. Let's have another example. Let's try sodium oxide. Sodium is in group 1 metal. We put Na for sodium. It's got its 1 outside electron. Oxygen is in group 6. So we draw the 1, 2, 3, 4, 5, 6 outside electrons. You will see sodium will want to lose that 1 electron. Let's do that straight away. Nice and easy. Over he goes. Electron going in there. Let's not quite finish that yet. Let's go back to the sodium. Sodium's lost that 1 electron, hasn't it? Yeah. So remember, losing a negative charge, one negative charge, it becomes +1. I can write it as +1 or 1 plus. It doesn't matter the order at which you write it, as long as you've got the right charge and the right number next to it. So sodium's very happy. Let's go and look at oxygen. 1, 2, 3, 4, 5, 6, 7. We're still deficient by 1 electron. But remember our trick. We can use another sodium, because sodium has that 1 electron. Oxygen needs that 1 electron. They can both help each other out. Off he goes. In he goes. Let's get rid of him there. Now, happily, we can write sodium as the +1 charge because it's lost it. Let's go back to the oxygen. Now it's got 1, 2, 3, 4, 5, 6, 7, 8. Very happy. It's got those 2 extra electrons. So I'm going to write that as 2 minus or -2. So now everything's happy. We've got our sodium ions and we've got our oxide ion. Don't call it oxygen anymore. It's no longer an oxygen atom. It's got 2 more extra electrons. So it's the 2 minus. Let's think about the formula again. Na. I've got 2 of them this time. So I put a little 2 there, and I've only got the 1 oxygen, so I will put just O. So my formula is now Na2O. Leave you one to have a go at. Have a look at aluminium oxide. At the start of tutorial 3, I will run through the answer, see how you get on. Best of luck, talk to you soon.